8.3 slope. We should be on page 378. Page 378 in your books. First of all, let's talk about what is the slope of a line. What does it mean when I say find the slope of a line? Well, I mean, basically, how is it slanted? The difference between each one of these lines on these graphs is how it's slanted. Okay? So we need to make sure that we always read the graph left to right. So in A, my graph or my line is slanting, it's going up and to the right. So I would say that this has a positive slope because it's going up and to the right. On B, I would say that this has a negative slope because it's going down and to the right. Remember, I'm reading it left to right. Starts in the upper left and it goes down and to the right. Okay, so on B, I would say that this is a negative slope. And then for C, anytime you see a horizontal line, it's not sloping either way. So the slope would be 0. The slope would be 0. Okay? And these are basically, whenever you're trying to find the slope and it already has the line on the graph, the first thing you want to do is you want to actually look at the line. If it's slanting up to the right, you know it's positive. If it's slanting down to the right, you know it's negative. If it's straight across, the slope is 0. Okay, this is going to be on your homework tonight, so if you're struggling, just go back and watch the video. All right, now let's talk about the formula for finding slope. The formula to find the slope of a line is rise over run. So, rise over run. So, on the coordinate graph, you have x and y. Which line do you think represents the rise? The y-axis or the x?
Y.
The y, up and down. So between 2 points, how much does it rise? That's going to be your y value. And then how much does it run? Okay, that's going to be your x value. How does this translate into an actual problem? Let's look at it. Okay? All right. Hold on a second. Just gave away the whole thing. Okay, so on your first 2 quadrants that you've already written, okay, this is example 1. I want you to go ahead and just number those graphs, okay? So remember, you can go by 2s as long as you're skipping a line in between. Go ahead and fill in your coordinate planes, and then I'll show you how to find the slope of a line. Okay, and say I gave you this point right here on A, okay? I gave you this line, and I plotted the points at 1, 2, and this point is plotted at 5, 4. Okay? Now, in order to find slope, I need to divide rise over run. So the first thing I want to figure out is how much did it rise? All right, and you see that's my blue line right there on the graph. In order to get from the first point to the second point, I need to go up 2, that's my rise, and over 4. So how do I write that? 2 over 4, and that would be 1/2, and that's my slope. Rise over run. Between the 2 points, the distance rose by 2 and went over by 4. So 2 over 4, that would be 1/2. Okay? And we know that it's slanting up and to the right, so it's positive.
So be 1/2 positive? Or just...
What if I gave you this line on B? Okay? Now, before you even try to figure out the slope, what can you tell? You can tell whether it's positive or negative right off the bat before you even do anything. Is this positive or negative?
Negative.
It is a negative slope. So I know that my answer has to have a negative in it. Okay, that my rise will be negative. Now I need to figure out from the first point, -1, 3, to the second point, 2, -1, how far did it rise or fall, okay? How many units did it take to go from 3 to -1? And that would be -4. From the first point to the second point, I went down 4 units, okay? And then my run is 3. So my slope is -4 over 3.
Are the units the boxes?
The units are the boxes. Okay? But even if you don't have the graph paper, you can use the coordinates to figure it out. How do you get from 3 to -1? It's going to be a total of 4, an absolute value of 4 units. All right, and that's how you find the slope of a line. Now, on example 2, we're finding the slope as a rate. Okay? So in your third graph, it needs to look something like this. And notice that you don't have to label your negatives because we're not dealing with negatives here. All right? Now in example 2, it's basically telling us that lava flows a certain number of miles in an hour. Okay? And it gives us the point 4, 6. Now, using our point of origin as our starting point, how can I figure out the slope? How can I figure out the slope here? All right, that's the question. Right, so what is my rise here between the first point and the second point? Between my point of origin and the 4, 6 coordinate, what is my rise?
6.
It is 6. The distance between 0 and 6 is just 6, or 6 miles. In this case, we need to label. Over, what is my run?
1.
My run?
4.
It is 4. I go from 0 to 4. And now, but it's not asking me how much in 4 hours. It's asking me how much in 1 hour, so I need to find the unit rate. I divide top and bottom by 4, and I get 1.5 miles an hour. All right, this is very similar to your homework, numbers 5 and 6. Okay, it's very similar to numbers 5 and 6 in your homework tonight. And then you'll have some more of this on your homework tomorrow as well. And that's all you need to know for part 1 of 8.3 slope. We'll finish the rest tomorrow.